So let me just bring that last example with the Newsgroup 20 data set. I'm going to search for one particular project here. This is our OpenAI embeddings example based on that Newsgroup 20 data. If I look at the model schema here on the input side, right, we'll see all of the dimensions of our embeddings vector. So this is 256 elements of that vector that represent the embeddings that are being fed into the model to make those decisions. So this isn't representative of the raw text input. We're actually passing the original text in as metadata, so we can visualize it, we can query it when we analyze the model. But ultimately, what we're trying to track in terms of the feature inputs are distributional changes tied to that embeddings vector. This happens to be a multi-classification model. It's predicting the likelihood that the text falls into one of these classifications. And then we finally have our target. But if I move over to monitor this, this is our embeddings vector that we're monitoring as a whole. We're not monitoring it as an individual element of that vector. And let me go back a little bit further in time so we can look at all of the traffic that's been fed into this. So this requires us to have published in, looks like over about the past, let's call it 2 months, traffic. We've been publishing in the inferences to Fiddler to track this drift on the input here, the embeddings vector. So we're sending in about 200 inferences a day. We can bin this by the hour if we choose. If I look, maybe at a smaller point in time, I can look at this by the hour. Obviously, we'll see a tad bit higher take on drift when we look at a smaller bin size. So I'll go back to day here. What we're seeing is that in this example, in our demo environment, we've actually introduced some artificial drift by withholding certain concepts that were present in the baseline, or over delivering or over publishing other topics. We've introduced drift that represents those changes from the baseline distribution. Now, what Fiddler is doing, we're actually mapping each inference into those clusters. So if I look at a point where we have relatively low drift, like we do here on March 4th, you'll notice that the orange data, which is the cluster assignments of the baseline data, could be your training data, could be inferences that happened last month. The blue data is pretty closely aligned. The assignments of the inferences to those 6 clusters is pretty similar on March 4th. Now, if I contrast that to a period of high drift, we'll see that those assignments are actually quite different. Cluster 6 is getting a lot more assignments than some of these other clusters on this day here, and this is March 2nd. So something's changed, and Fiddler's here to proactively send you alerts if these sorts of changes go above a threshold that you care about. The next thing that we're working on as a company is to actually help you take that next step, right? You can move over to analyze, and you can start to query this data and start to understand, just looking at the inferences and the original text that occurred on March 2nd, what's different about it that might be explaining this drift that we're seeing. But we're working on some other things that I'm going to bring to life here. By layering in this 3-dimensional UMAP or 2-dimensional UMAP visualization, you can start to get a sense for where those actual outliers are. So when you see things like, cluster 3 getting more assignments than it did in the baseline, you can just click on just looking at that cluster, and then you can click on these individual data points in this 3-dimensional visualization and start to see the unstructured data that is responsible, whether it be that an image, be that the original text for an NLP model, so that you can really start to get a sense for where the outliers are and what's causing them to be outliers. So you can actually get a better sense for what's the root cause here.
Try Fiddler free for 14 days.